Okay, so 10.2 is all about probability um, and pretty simple probability. I think most of it is stuff you learned last year in 7 plus. Um, but if we're just looking at a definition, general definition of probability, um, probability is just the chance that something will happen or how likely something is to happen. Okay, and if you need to pause the video to get these written down, that's fine, because I'm going to go through them kind of quick. So the probability is the chance that something will happen or how likely something is to happen. There are two types of probability, and probability is always between 0 and 1. And one way that you can calculate probability is what's called theoretical probability. So theoretical probability is the probability of something happening determined by calculations, or you can think of it as what the chances of something or the probability, what it should be in a perfect world. So, you may flip a coin 3 times and get heads every time, but theoretically, if you flip it twice, you're going to get 1 head and 1 tail. So that's kind of what theoretical means. Experimental probability is the probability determined using the results of an actual experiment or trial. So again, say you flip a coin 3 times and you get heads 3 times, or flip it 4 times, get heads 3 times and tails once. You would say the experimental probability of getting a head is 3 out of 4, or getting a tail is 1 out of 4. So that's experimental probability. Theoretical probability is calculated by doing a fraction, the number of ways that a desired outcome can happen over the total number of possible outcomes. So if we're looking at heads versus tails, there's 1 way to get tails and 2 possible outcomes. So the probability of getting tails would be 1 over 2. Okay, and I'll explain this notation right here on the next slide. Okay, so an example, as part of her job working with the forest, Chandra tagged a total of 1,470 squirrels last year. She tagged 820 black male squirrels, 100 black female squirrels, 380 gray male squirrels, and 170 gray female squirrels. If this distribution accurately reflects the squirrel population, what is the probability that the next squirrel she tags will be a gray male squirrel? So the way that we can figure out the probability of a gray male squirrel, and this is the notation I was talking about. So a lot of times you'll see it written as just P for probability, P, and then parentheses gray squirrel is the total number of gray squirrels in the forest over the total number of squirrels, any type in the forest. Okay. So if there are 380 male gray squirrels and 170 female gray squirrels, then we've got 380 plus 170. That's how many gray squirrels there are over 1,470 total squirrels in the forest. Okay, so that gives us 450 over 1470, which I'm just going to figure out as a decimal real quick. As a decimal, that's about 0.31, or about 31% chance that the next squirrel would be a gray male squirrel. Okay, so if we're looking for the probability of a female squirrel, I'm going to write the notation this way: P female squirrel and then we want the number of female squirrels over the total. So our total hasn't changed. That's still the 1470. And there are 100 female squirrels plus 170 So 270 total female squirrels. We find that as a decimal. That's about 0.18 or about 18%. If we're looking for a probability of red squirrel, if we go back and read this problem, there are 820 black male squirrels, 100 black female squirrels, 380 gray male, 170 gray female. It doesn't say anything about red squirrels. So there are exactly 0 red squirrels in a forest of 1,470 squirrels. Okay, so that's pretty easy to calculate. There's a 0% chance that the next squirrel she tags would be a red squirrel. Okay, so like we said, a percent or a probability is always between 0, which is impossible, and 1, which is certain. Okay. The next example, you've got 20 candles, 4 of them vanilla, 2 orange, 6 strawberry, 5 cinnamon, 3 winter scented. If they're all put in a bag, what is the probability of randomly selecting each type of candle? So if we want the probability of selecting a vanilla candle, there are 4 out of 20. The probability of selecting an orange candle, 2 out of 20. And I'm not going to simplify these fractions. You can if you want, or you can write them as a percent if you want. But I don't think we need to take the time to do that. The probability of strawberry would be 6 out of 20. Probability of cinnamon would be 5 out of 20. And probability of winter would be 3 out of 20. Okay, so those are all our different probabilities for each different type of candle. What is the probability of randomly selecting vanilla or cinnamon? If we're looking at probability of vanilla or cinnamon, there are 4 vanilla and 5 cinnamon for a total of 9 out of the 20. And what type of probability is this? This is a theoretical probability because we haven't actually done the experiment. We haven't actually taken 20 candles and seen, you know, if what are your chances of drawing vanilla, for instance. Okay, so since we haven't actually done the experiment or the trials, it's a theoretical probability. Okay, because it's what we would expect to happen, but we haven't actually tested it. So here's your before class question. You're going to need to figure out some probabilities for yourself based on the results of an experiment given up here.